All right, good morning, everyone. Happy Wednesday. I hope you're all doing well and that everything went okay yesterday with the video. If you do have any questions about any of the logarithms, either yesterday's assignment, what we're doing today or tomorrow, please don't be afraid to reach out via email and ask me for help. Don't be afraid to go to either Miss Matthews or Mr. Long and ask them for help. Because I will not be back until Monday. So we need to make sure that just because I'm gone, we're not learning. I think is that the right notation? Something like that. So we're gonna get started with today. The answer key to the assignment from last night is on Schoology, so if you want to go check on in that folder, it should say the answer key for yesterday's assignment. Sorry, the handwriting's really bad. That's just the way it is. But you should be able to check your work. If you think I made a mistake or something, let me know. But please keep all of your assignments because when I get back on Monday, I will check all of them off. But yeah, so the answer key should be in the folder and you can look back on that. All right, go ahead and pause this video if you want to take a moment, write these down in your notebook. These are your entry tasks for today, and this is reviewing what we did yesterday. So the first one is an expanded log, so 5 log base 3 of x plus 6 log base 3 of y minus 2 log base 3 of z. We want to write that as a single logarithm. And then number 2 is the opposite, so writing the single log in expanded form. So log base 5 of 5, a, b, c all squared. So take a moment, write those down, maybe pause this video, and then I'm going to just continue in and show what they are. All right. So let's look at this first one here. When you have parentheses like you do around this 5 log base 3 and this 6 log base 3, we always kind of want to start from the inside and work our way out. So those parentheses are important to kind of group those. First thing I'm going to do though is whenever I have a whole number out in front of my log, I'm going to bring that up to the exponent using my power property. So that's pretty much the first thing I always do. So log base 3 of x to the power of 5 plus log base 3 of y to the power of 6. Now this subtraction sign is going to stay there. It's not a -2 that's going up to the exponent. The subtraction sign is going to stay there, so it's just a +2 that goes up to the exponent. All right, once all of those are done, then we're going to go ahead and use the parentheses to condense everything down. So I'm going to combine what's inside the parentheses. Addition changes to multiplication. So log base 3 of x to the power of 5 times y to the power of 6 minus log base 3 of z squared. So that's what the parentheses are important, because we want to make sure that the x and the y are together. And now, by having that, when I go to simplify the final way, subtraction changes to division. So your final answer would be log base 3, where x to the 5th and y to the 6th are in the numerator, and z squared is in the denominator. Notice that I only have one log written, right? Write it as a single log, so you do not want to have 2 logs. It should only be 1 log, and then the division symbol is usually kind of like halfway in between the two. All right, let's do number 2. So number 2 is the opposite. So I have log base 5 of 5abc squared. Same thing as before. The first thing I'm going to do is I'm going to bring this 2 out to the very front. So my power property. So let's see if I have enough room to do this. This will be 2 log base 5 of 5abc. Ooh. With the handwriting. I think you get what I'm trying to do though. All right, now since the 2 is in front of the log, as you go to expand it, that 2 needs to go in front of every single log. So this would be, let's see here, this would be 2 log base 5 of 5 plus 2 log base 5 of A plus 2 log base 5 of B plus 2 log base 5 of C. So because A, B, and C are all being multiplied together. When you expand them out, we're using addition every single time. The only other thing that we can do is we can actually simplify this 2 log base 5 of 5. Log base 5 of 5 is actually just equal to 1. So this is really just saying 2 times 1. That's using just evaluating logs and the base property. So really 2 log base 5 of 5 just changes to the whole number 2. So moving forward, we're going to need to look out for those little simplification details. I would hope that you could for sure do the step previous. If you didn't see that simplifying part, that's something we're going to just need to practice and look out for in the next few days. But yeah. So that would be, I think that's all the way expanded. You usually don't have any exponents in expanded form, so I wouldn't bring those 2's back up. Everything usually is brought down to the front when you're in expanded form. Versus there's exponents, I guess, in number 1 when it's a single log. So yeah. All right, let's move on. Okay, today we are going to move on to section 2, so chapter 2, section 2. Today we're going to be looking at 2 different things. The first thing is we're going to be looking at what's called the change of base formula. Really, you only need the change of base formula for those of us with the calculators that you can't change the base. So if you are somebody that has one of the fancier calculators, then you probably won't need to use the change of base formula. So the change of base formula is really for when we're just using like a standard scientific calculator. You can still use it with the big fancy ones, but on the fancy ones, if you can just change and manipulate the base, then you won't really need this formula. After we look at the change of base formula, we're going to actually be starting solving, and today we're going to be solving exponential equations using logarithms. You can use a calculator today. You're not going to want your phone calculator. You can use the phone calculator. There is a log on the phone calculator. You just have to unlock your screen and switch it so that the phone is horizontal. And then there should be a button that says log base 10. So you can use it, but I would recommend borrowing one of my calculators just because the phone's kind of annoying to type numbers in. I don't know if that's the touch screen or what it is. So if you need a calculator, they're in the back, in my big black cabinet in the back of the room down on the left-hand side. So you'll see a big box of them, and then you can borrow them, but please make sure that they get put back. All right. So change of base. Before we do the change of base formula, I want you to be aware of something about the calculators. So in math, we have something that is called the common log or the common logarithm, and that is considered log base 10. You will never, ever, ever, ever see 10 written as a base. In math, it's always just looks like log of x. Your calculators, the calculator on the phone, the log button that's already on your calculator, those are already programmed to have a base of 10. It's considered a common log. If you are ever using logs in the real world, generally we use base 10. It's just the most common. I feel like that's redundant saying it's the most common because it's called the common log, but that's just is what it is. So in your calculator or moving forward, whenever you see this log of x, please know that that is the common logarithm and that has a base of 10. The 10 is just not written. The 10 is not written. Okay, so on your phone calculators, if you aren't changing the base, just the normal log button already has a base of 10 programmed in. Okay, so if you have a calculator where you can change the base, usually you can just find it on most calculators. You go math and then scroll of the fancy ones, scroll down to like option A, I think, math option A, it says log base. If you can change that and change what the base in the M is, that's fine. But if not, we're going to be using this formula here, this log base 10 of 10. So I'm going to give you a moment to write this down. really, the formula is kind of nuancy. I'll kind of show you what it'll look like when we type it in. But if you have log base b of m, and you are trying to evaluate that using a calculator, and you cannot change the base in your calculator, we use this formula. The formula you would use is that you would have log base 10 of m divided by log base 10 of b, where m is the number of the log and the b is the base of the log. The 10 won't be written there though, so it'll kind of look more like log of m divided by log of b when you type it into your calculator. And I'll show you what that looks like when we do an example. Okay, but technically this is the change of base formula. If you don't have one of the really fancy calculators, then you would have to use this formula when you're trying to evaluate. So let's look at it. Okay, so use the change of base formula. What is the value of each expression? So if you have a calculator you can change the base, you can go ahead and just type it in as is. If you do not have a calculator where you could change the base, this is what you would type into your calculator. You would type in log base, oh my goodness, no. You would type in, rewind, you would type in log of 32 divided by log of 8. And I think I have that. There it is, log of 32 divided by log of 8. So in your calculator, this is how it would look when you type it in if you cannot change the base. Okay, if you can change the base, that's totally fine. But if you cannot change the base, this is what it's going to be. Okay, so when you type that in, you would have log of 32. The 32 has to be the one in the numerator. Make sure you close the parentheses and then hit the division button and then press another log. It's kind of annoying, but it's really important that you click all of the correct buttons. And when you do that, you should get 1.6 repeating, I believe. 1.6666667, which is really just 1 and 2/3 or 5/3. For this chapter, a lot of the problems are not going to be whole number answers, so I can't remember if on the homework I said round to the nearest 100th or 1,000th, so it's either 2 or 3 decimal places. I can't quite remember. If you wanted to write this in exact form, it would be 5/3. All right, so then let's look at example B. So that's really all it is. So for example B, you have log base 4 of 18. If you have a calculator where you can change the base, then you can go ahead and just type that in. If you don't, we need to use the change of base formula, and you would type into your calculator log of 18 divided by log of 4. You don't need to do anything else, just press the regular log button, and it should look something like this. I'll give you time to type it in, make sure it's all good, and if I'm going too fast or anything, you can pause. But I believe this one is a decimal, and so I got 2.0849625. So if you rounded this to 3 decimal places, your answer would be 2085. All right, so change of base formula really is only necessary if you can't change the base on your calculator. If you can change the base on your calculator because you have one of the fancier ones, then you can just do that. But if not, you would have to use this formula here. You will not get this formula on a test or quiz, so make sure you have it memorized. All right, let's keep going. All right, I'm gonna let you pause this, try this real quick, and then we'll move on. So same thing, change of base. What's the value? If you already have something in your calculator where you can just change the base, then do that. If not, how are you going to type it in? Really, for these, I guess I don't need to see a lot of work. If you wanted to write down what you're typing into your calculator just to be safe, just in case you accidentally type the wrong thing in, then you could do that, but it's really just, I guess, personal preference. Just make sure that you have, oh wow. Oh, I'm getting all backwards. Ah! Okay, wait a minute. I think, okay. Wow. I just got all, too many slides. Okay, I think we're okay. So when you type it into your calculator, this is what you should get. You should get 1.20557. And then, sorry, that was like, gosh, you know, technology, just such is my life. Such is my life. And if you rounded that to 3 decimal places, we would get 1.206. And then you can go ahead and do the same thing for B. You can see by using your phone, this can get a little clunky, so that's why, because it's already kind of clunky with the calculators, so you can kind of see why it would be nice to use a calculator over the phone. But log base 7 of 30, you do log of 30 divided by log of 7, and you get 1.748. All right, pretty self-explanatory. If you have any questions, though, let me know. Ask an elbow partner, help each other out. Or as always, you can go check in with Miss Matthews or Mr. Long. All right, let's get into the second part of our learning target, which is solving exponential equations. I have 4 steps here. You can pause and write them down. I'm going to kind of explain them as I go through. But yeah. So step 1, get the value raised to a power completely by itself. So I have 15 to the power of 3x equals 285. Now, the reason this is an exponential equation, oh, I thought that was going to be highlighted. The reason this is an exponential equation is because the x is in the exponent spot. And so when we solve, it's a little bit complicated, or a little more complicated. So step 1, get the value raised to a power completely by itself. Technically, step 1 has already been done in this problem. The next example, I will show you what step 2 or step 1 looks like because it won't be done. So in this one, step 1 is already done. The value that's raised to a power is already completely by itself, meaning there's nothing being added or subtracted to the 15 3x. Step 2 is probably the most important step because in order to solve this, when you have a variable in the exponent position, the only way we can solve is to take the log of both sides. And I'm just going to take, you could I guess take the log of any base, but we always use log base 10 when we're doing this because that's what most calculators are programmed with. So I'm going to take the log of both sides. So I'm literally just going to go log of 15 to the 3x equals log of 285. I can mathematically do this because technically, as if you're solving, whatever you do to one side of the equal sign, you do to the other. So mathematically, this is allowed because of that. All right, second thing, step 3, once you take the log of both sides, then we need to use the power property of our logarithms to bring the exponent down. So we have to bring that 3x down so that it is no longer an exponent. And so by doing that, I'll have 3x times log 15 equals log of 285. Now that the x or the variable is no longer in the exponential position, now we can go ahead and solve for x. So we're just going to do step 4. So we're going to divide both sides by log 15 because I need to get x by itself. So I'm going to divide both sides by log 15. That way my log 15s cancel out and I have 3x equals, I'm going to type into my computer. I'm going to type into my calculator log of 285 divided by log of 15. And I get a very long decimal. I'm not going to round it yet because I don't want to round too early because then it'll just kind of set my answer off. 91136. And then last step to get x by itself is to divide by 3. And we'll round to 3 decimal places. So then divide by 3, I get 0.696. And that is my final answer. Voila! We solved for x. Now you could check your work. It won't be exactly, but if you did 15 to the power of 3 times 0.696, it should be fairly close to 285. I think it's technically actually a little bit larger. That's due to rounding. That we get into a lot of different nuanceful things with that, but it should be very, very close. So yeah, that's the first one. Let's look at number 2. So same steps, because this is an exponential equation because I have x in the exponent. So I have 9 to the power of 2x minus 6 equals 60. Pause if I'm going too fast. These steps are all the same, so you shouldn't have to rewrite the steps down. Step 1, we do get to actually do this one. So this problem, my 9 to the power of 2x is not by itself. I have this minus 6 there, and so I need to move that minus 6 first before I can go ahead and take the log of both sides. So the first thing I'm going to do is actually add 6 to both sides. So 9 to the 2x equals 66. And so that would be considered the first step of getting the value raised to a power completely by itself. Once I do that, now we can go ahead and do step 2, where we take the log of both sides. I use the the common log, so log base 10. Oh, that's a highlighter. There we go. So this would be log 9 to the 2x equals log of 66. Step 3, now we're going to use the power property to bring the exponent down. So you can only do this once you take the log of both sides. But once I've taken the log of both sides, now I'm going to take this 2x and bring it down to the front. So that would be 2x times log of 9 equals log of 66. And then step 4 is to divide and solve for x. So now I'm going to divide both sides by log of 9. I guess I could divide by the 2 also right away. There's more than one way to solve a problem, so I'm just kind of going really step by step here, but I guess if you wanted to, you could divide by 2 log of 9. Once again, just make sure that you're really being mindful of how you're typing it into your calculator. So I have log of 66 divided by log of 9, and that gives me 1.9067946. All right, and then we're going to divide by 2. And I get x equals, I'm going to round to 3 decimal places now, 0.953. 0.953. Voila! All right. I think we have one more. Last one. 25 plus 8 to the power of 0.2x equals 98.6. This is pretty much all the same steps. There's really nothing new here. It's just practicing the same thing. So I know it's an exponential equation because x is in the exponent. Step 1, I need to move the 25 to the other side first. So minus 25. Whoa, that's an ugly 25. So I have 8 to the power of 0.2x equals. You can show as much or as little work as you feel necessary. I would like to see some of the steps just so that way I can kind of see your process. Plus, if you don't show any work and you get it wrong, then I can't give you any partial credit. So show some steps. I'm not super nitpicky about needing to see everything. But if I can't really understand your thought process, then I can't give you partial credit. So just kind of keep that in mind. when you are working on these problems. All right, you can take the log of both sides. All right, let's bring that exponent down. And times log base 8 equals log 3.6. So I just did step 3 there to bring the exponent down. And now we'll divide and solve for x. So let's see here. So we're going to divide by, so I guess if you wanted to, you could divide by 0.2 log of 8. 0.2 log of 8. Just once again, be really careful with how you're typing that into your calculator. That's kind of the biggest issue or mistakes that I tend to see with these types of problems, is not necessarily that you don't know how to do it, but that you, for whatever reason, accidentally type it into your calculator wrong. So please make sure that you are practicing the calculator part of it, only because I would really hate to have to mark you wrong just because of a calculator thing. I got 10.336, if I did that right. All right, boom, there we go. That's it. So that should be everything. Your homework assignment, the sub should have a hard copy that you can work on now. I will have the answer key posted tomorrow. We will be learning new content tomorrow as well, and then Friday is just going to be a review work day of everything we've done this week. So like I said, please make sure you're keeping up on your work. If you have any questions, issues, or concerns, email me. Help each other out. I'm sorry this timing is really bad, but that's life. So put your independent learning hats on and make me proud. I'll see you Monday. Bye.